Yeah, so in the last class we were looking at some examples of data types, right, in C sharp. Um, so like we have mainly these, there are some more data types, but these are the most regularly used data types: byte, short, int, long, in integer or integral numbers, and then in real numbers we have float, double, decimal, and character is a separate data type, and bool is a separate data type. So byte is 1 byte. So the range of numbers which you can store, if it is very small range 0 to 255, then you can use byte. If it is between, say, some thousands, like between 30,000, then you can use short int, and then very large, I mean, for most of the purposes int will suffice. If you need much more large numbers, then you use long. Okay, and again within real numbers, for smaller range you use float, for a larger range you use double, and for a much larger range you use decimal. All right. One way of saying it is precision. So when we say double, more than the range, it is about precision. So double has double precision when compared to float. That's why float in .NET type, it is actually called single. Okay. So these are C sharp types. This is what we write in the code, but at the back end, this is how they are sort of converted. All right. So if you actually see the code, you see what is it saying? Read only struct system.single, because float C sharp type is equivalent to .NET's .single type. Okay, and say double in C sharp is equal to floats dot double, and int in C sharp is equal to int32 in .NET. All right. So when you look at these system dot something, you shouldn't get confused. You should understand that this is the internal way it stores the data type. Okay. Yeah. So decimal is stored as capital decimal. So the precision of double is double the times of float, and decimal is of a higher range as well as higher precision than double and float. So like I said in the last class, for many scientific applications we need a very large precision for decimal, maybe up to 100 places or 200 places of decimals. If we want that precision, then you use the decimal data type. Okay. And char, it is similar to char in C, which is used for characters, but it is also fundamentally different from that, in the sense that char in C is actually of integer type. Okay, you can assign an integer also to char, or you can assign a character also to char. Finally it takes it as an integer only, but here char is fundamentally a character type only. It is not of, although finally it is converted to integer, but you can't treat it as integer in the code. All right. And char in C is of only 1 byte, whereas char in C sharp is of 2 bytes. So the range of characters that you can store in C sharp is much more. So if you actually put it here, yeah, and it says system.char. Below that you read line represents a character as a UTF-16 code unit. So like I said in the last class, ASCII is one way of encoding characters, but its range is small. Maximum 255 different kinds of characters you can store, because it is only 1 byte. 1 byte means 8 bits. 8 bits means 256. So maximum 256 different kinds of characters you can store in 1 byte. Whereas if you make it 2 bytes, it means 16 bits. So 2 power 16 different kinds of characters you can store. So now you can accommodate non-English characters or different kinds of languages characters or emojis, many more kinds of characters. So char in C sharp is of Unicode type, not ASCII type, whereas char in C is of ASCII type. Okay. And Boolean, you all know, true or false, these are the only two values that it takes. So this allows you to do Boolean logic, like in if else conditions, if this is true or false, those kind of scenarios, you use bool. Okay. So let us look at a couple of more things. All right. And one more thing I mentioned in the last class, when you are using real numbers, if you are assigning a real number to a variable, it can be float variable or double variable or decimal variable. By default, it will assume the number to be of double data type. So if you want to say that number should be stored as a float, you should give this suffix f. Only then it will store it or it will assign it to a float variable. Suppose if I remove this f, you see it's showing some red line. So what is it saying? Literal of type double cannot be implicitly converted to type float. So it knows that the variable is of type float, but you are giving a number of type double. So it is getting confused. It treats it as an error. So if you try to compile it, it will not compile. That's why it is showing a red line. So when you see some red underlines, it means it is an error. Okay, so you need to resolve that before you compile your code. So to resolve this, you have to put f. You see now the red line has gone. Similarly, when you want to assign some real number to a decimal variable, you have to say that real number is of decimal data type. For that, you should again put this suffix m. If you remove this, again, it will be an error. It will try to treat this number as double, but you are trying to assign a double type number to a decimal type variable. So it will not allow that. You need to say this is also a decimal type number. So put m. Okay, then it will allow. If it is double directly, you need not put any suffix because that is the default type. Okay, so these are some things. And yeah, and there is one more, that is string. We will discuss strings in detail later, but I'm just introducing it as an example. So name equal to whatever, say Hyderabad. You see, string, any string is put in double quotes. Okay, any char is put in single quotes. So there is a difference. If you want to assign a character, you should put it in single quotes. If you want to assign a string, you should put it in double quotes. Okay, it's just warning. It is saying name, you have assigned some value to it, but you did not use it. So we will use it. Okay, now let's run it. So let me run it again. Okay, I'm in a different folder, so I need to change the folder. Yeah. Yeah, it printed all the values. Okay, so that is one thing. And another thing is, so far we looked at only variables, right? These are all variables, you know, variable data type, variable name, and value. All right. Another thing that I mentioned is, if you don't give a value to the variable and you try to use it, it will not allow you to use. Here you see a red line because you did not assign any value to name, but you're trying to print it, you're trying to use it. It will not allow that. That will be an error. Okay, it says use of unassigned local variable name. So you can even try to run it, it will not run. It's giving an error. All right, but in C, it will not give an error. It will print something, some random value. But here you cannot even run the code. It will end with an error. Okay, so it's important that you assign a value to a variable before you use it in anywhere, either to print it or to add it to something or in some expression, arithmetic expression, whatever it is. Before you use it, that variable should be assigned a value, otherwise it will not allow you to use it. Okay, and so far we looked at variables. Now suppose we want to define a constant, right? That is, we should not change that even by mistake, Right now, let's take any variable that we declared. Suppose here I declared ch to be a. In the next line, I will say ch to be b. Okay, that will work. So here, when I print ch, it will print b, right? So let's run it. You see, it printed b, which means ch got updated. But suppose I declare another variable called, say, float pi value 3.14, let's say that, but here I have to say 3.14f. Okay, now pi is basically usually a constant, right? We don't change it, right? So if I leave it like this, suppose somewhere you forget and somewhere later in the code by mistake you change pi to be whatever 5.23, it will allow that, right? So if I print it, so it is printing 5.23, but that is not the value of pi, right? So we don't want pi to be replaced even by mistake, right? So to avoid that, what to do? You have to give a value to pi. You create a variable called pi, you give it a value, but you want that value to be fixed, not changed later, even by mistake. Yeah? Assign? Declare it as a static variable. No, static does not mean fixed variable. Static has a different meaning. Static is usually used inside a function. So, for instance,
Use a variable without instantiating.
no, variable does not have instance. Suppose in C, how will you do? In C, there is no concept of class and instance. No, so there also, in any programming language, whether it's object oriented or not, there should be a way of fixing variables values. No, global variable also can be changed. Global does not mean static. Does not mean it's a fixed. Basically, static means, say, suppose you have any function, usually the variables inside the function are local to that function. Once you come out, the variables disappear from the RAM, and suppose if you call that function again, that variable will be again declared with that value. So let me static in the sense, suppose I'm giving C code example. Suppose I have some function, say counter, okay, and this just has some variable called count 0, and then all I will do is I will do count plus plus. Okay, the number of times this function is called, it will increment the count. That should be the idea, but so here you say int x equal to counter, or let's say int x equal to int x equal to counter, and then, or you need not even give int x, you just say print counter. Okay, now suppose if I again call print counter, what will it print? First counter, what will it print? I mean, actually here I should not say print counter. Here I should say print count. And here I will just call counter. When I call counter, it will print in the function, it will print. What will it print here? What will the value here will be? Yeah? 1. What will the value here be? 1 only. Because next time you call, again count will be 0, again it will become 1, again it will print 1. So no matter how many times you call, it will just print 1 only. But suppose I want it to actually keep track of the count. I don't want this count to disappear the moment I come out of the function. Okay? In that case, we make this static int. So now even when you come out of the function and when you call the function again, the old value of the static variable will be there in the memory. So static variable means that variable is stored in the static portion of the memory. That is not dynamic portion of RAM. Dynamic portion will keep getting updated, but static portion remains as it is until your entire program is exited. So when you come back to the function, the static variable's old value will remain as it is. So if you called the function 3 times, then count will be 3. Now when you call it 4th time, count will become 4. So it starts from 3, not 0. Okay, so that is a static variable. Static does not mean fixed variable. Here count is changing. It is changing from 1, then 2, then 3, then 4. It is changing. But static means it is stored in the static portion of RAM. It is not erased immediately. That is static. Okay? Alright, so static is not the solution in our case. I don't want to change pi at all, even by accident. What should I do? What is pi in mathematics? Yes, irrational number, but pi, e, what are these? Yeah? Constants. So I should define it like a constant in my code. Alright? So there are something called const variables. Basically const variable is a oxymoron. Const cannot be varied. So we have constants and variables. So pi is a constant. So if we want to define it as a constant, we just need to put the keyword const before the variable declaration. Now you cannot change pi later even by accident. Okay? So here you see, now there is a red line. It is saying the left hand side of an assignment must be a variable, property or indexer. But ours is a variable. Why is it saying that? So technically ours is not a variable, ours is a constant. Okay, now you can't change it. So it is an error, so you can't compile it. That's it. So to be careful that when you know something is a constant, put a const keyword before that. It cannot be changed in future even by mistake. Okay? If you don't put const keyword, if someone changes it, entire program is disturbed. Alright? So we can use constants and we can use variables. How do you define a constant? Just by putting a const keyword before the variable declaration. Okay, earlier we just said float pi. Later we just added this const keyword before this variable declaration. That made it a constant. Okay, so that is the difference. All right. Now I removed the line which makes your which tries to replace the const value. So now the code will work. All right. Yeah, now the code ran. Okay. Okay. Now you have seen so far that you see every time we want to print something, we write console.writeLine, console.writeLine. This entire thing either we have to write or at least we have to type the beginning of both these words, console, and then press tab dot write, press type some few letters, and then it suggests, and then you press tab, and then you write whatever you want inside. Rather than writing like this every time, there is a shortcut called CW. So this is called code snippet. So when you write this, it will give you the entire line. So it will give basically system.console.writeLine. Basically it is the same thing because console is a class in system namespace. So it will work. Okay, so we can run it again. You see it printed 3.142 times. Okay, so rather than typing console.writeLine every time, you just type CW. It will show you the suggestion. Press tab or enter. It will work. Okay. All right. Now one more thing. So all right, so I created a new file. I basically copied the previous project into a new project, and let me change this directory also. Okay, now I'm in a new directory. So let me close this, yeah. So you see, most of you will be familiar with Python, right? Yeah. In Python, do you declare data type name and then variable name and then value? No, you just say some variable equal to some value, right? It will automatically detect what data type it is. If it is a real number or integer or string or whatever, it will detect. Similarly, in C# also, we have similar provision, not exactly like that, but very similar to that. Instead of giving the specific data type name, for each variable, you can just give the keyword var. So instead of saying int, float, double, all these, any variable you can declare using the keyword var. Now it will automatically detect the data type. Okay. Now for you to see what did it detect, what data type did it detect as, you can just place your cursor on var variable. Okay. No. Int. Okay. Float. Yeah. So it's telling you what it is detecting it as. Right? So it is detecting height as float. It is detecting weight as double, radius as decimal, and so on. Name as string. Okay. Yeah. So you need not worry about the specific data type. But if you take this, actually we defined this as byte, but it is detecting it as int. Okay, so any integral data type, whether it is byte or short or int or long, it will try to detect it as int only. So if you want to explicitly specify the data type, you better use that specific data. Like if you want to explicitly say it is byte, use byte. Otherwise, if it doesn't matter to you, if it is mostly int or even if it is small number, it doesn't matter to you about space, you just use var. Okay? Yeah. All right. So anyway, this will also run. You can just see. Where is the error? Implicitly typed variables cannot be constant. Okay, yeah. So I cannot use const keyword for implicitly typed variable. So if I have to use const keyword, I have to say const float. I have to use the specific data type. Okay, so let's remove that one thing and run it. Yeah, now it ran. Okay, so here instead of const var, I will say const float. This will run. Yeah, okay. All right. Next, let's look at type conversion. So you all know type conversion, like suppose sometimes I want to convert a string with digits to an int, or some int to string, right? Or maybe some int to float or float to int, some many such similar scenarios, right? So similarly, say in C#, if you want to convert some one data type to another data type, there are basically three ways. One is implicit type conversion. Another is explicit type conversion, which is also called casting or type casting. And third is conversion of non-compatible types. So in C also we have implicit and explicit type conversion, but we don't have, we also have some conversion of non-compatible types. Do you know what is implicit type conversion, what is explicit type conversion? No? Okay. Let's take an example. Let's copy this again. Okay, so okay, let me close this now. So let me delete all these lines. Now suppose I said byte number equal to 20, and then I say int, so let me say here byte n1 equal to 20, int n2 equal to n1. All right. Now if I try to print n2, what will it print? Yeah, 20. It will just copy the value of n1 to n2, right? So to run that, I need to again change directly to this one. Okay, it printed 20. Okay, now let me do the reverse. Int n1 equal to 20, and I say byte n2 equal to n1. All right. Now what will it print? Will it print 20 or no? No. Why? Sorry? Byte is place value. It what? Prints some space place value. Who said that byte prints place value? So you mean, suppose if I had said byte n1 equal to 20, and then I said print n1, will it not print 20? Then so this was int n1 equal to 20, and then I try to assign it to byte. What will happen? Or suppose suppose I say int x equal to 5, float y equal to x, and if I print y, what will it print? So let me comment this. It prints 5, but it treats that y as a float only. Okay. Let's reverse it slightly. When I say float x equal to say 5.2, and if I say int y equal to x, now what will it print? Five. Okay, let's see. It's giving an error because when you are trying to convert into float, no problem. You just need to add a decimal value, 0.0 or something like that. But when you are trying to convert float to int, you are losing some data. You may or may not lose data. Suppose if you define float x as 5.0 and then you try to convert it to int, you're not losing data. But if it is 5.2 and then you try to convert to int, you're losing decimal values. Okay, so it doesn't care whether it is 5.0 or 5.2. If there is a possibility of losing data when you are converting from one data type to another data type, it will not run. Okay, so in such scenarios, you have to explicitly say that no, convert it. Even if I lose some data, it doesn't matter, convert it. All right. So in that case, we say int in brackets. Okay. Now let us see. Mm. Sorry, it is first of all expecting f. Okay, so let us give that. Yeah, so it is not converting because float to int you cannot convert directly. Now let us give this and then see. Yeah, now it converted. Okay, so earlier error was not because of this, earlier error was because I forgot giving f. Okay, so it has so some data is lost. Fine. In the previous case, when I wanted to convert into float, I did not need to give this converted. It automatically converted. Okay, so that is called implicit conversion. All right, but when I tried to convert float to int, I had to force it. I had to say explicitly that you do convert it to int by giving this int converted. That is called explicit conversion. Okay, so when it knows that, when it is sure that in some direction of conversion data is not at all lost, like when you are converting into float, data is not at all lost, or when you are converting byte to int, data is not at all lost, because int is a larger it's just a larger size when compared to byte, right? So all you need to do is just put additional zeros in front, right? So in the binary form, suppose if I say byte x equal to 5, now 5 in binary form is what? Yeah, yeah, it's 101. Okay, now byte means 8 bits, but these are only 3 bits, so what about the remaining 5? Yeah, suppose if I say you see, whenever you are in doubt regarding binary, you just convert your doubt into decimal number system. Suppose if I force you to use some 8-digit decimal number, and say my decimal number is whatever 534, I am using only 3 digits, but I force you to use 8 digits, then what do? My number has only 3 digits. Now how do I fill the remaining 5 digits? You add zeros in the front, right? Same thing in binary also. Your binary number is sufficient, it is fitting in 3 digits, but you are forced to use 8 bits. What do? Add zeros in the front, right? Add 5 zeros in the front. So now this is 1 byte. So byte will occupy 8 bits, whether all the bits are non-zeros or not. Okay, fine. Now, what about int? Oh, sorry, you should have told me. Yeah, sorry. So let me quickly repeat what I said. So when I say x equal to 5, so 5's binary form is 101, right? Now this is only 3 bits, but I want to use all 8 bits. So all I need to do is I need to fill the remaining bits with zeros. That's all, like any decimal number. Okay, so in case I miss showing the screen, please immediately tell me, okay, because sometimes I just look at this, I don't look at that. Yeah, now so 8 bits, 1 byte is filled. Okay. Now if I convert this to integer, what is the change that is coming? Yeah, it will remove the zeros. What is the difference between integer and byte? Yeah, size, right? What is the size of byte? 1 byte. What is the size of int? 4. Short int is 2, int is 4. Okay, so whatever data you are giving, that same data is being stored in 4 bytes instead of 1 byte. Okay, which means whatever is fitting in 1 byte will automatically fit in 4 bytes also, no? So, but whatever is fitting in 4 bytes need not fit in 1 byte. Okay, so this number 5, now same number, if I have to store in int, how will it be stored? It will be 101 and then all the remaining will be zeros. Total how many bits should be there? 4 bytes means 32 bits. So we have 3 bits gone for digits. So remaining all the bits should be zeros. So how many remaining bits? 29, right? So all of them will be zeros. So this is 1 byte. Next byte is all zeros. Next byte is all zeros. One more byte is all zeros, right? So 4 bytes, only in the 4th byte, last 3 bits are non-zeros. That's all. So it is easy, right? So if I am given a byte, converting it to int is very easy. All you need to do is add these additional zeros in the front. No data is lost, right? But if I have to convert int to byte, right? If the integer fits within this last byte, no problem, no data is lost. But if the integer comes here also, then this data will be lost, right? So that is why it does not allow implicit type conversion when you try to convert int to byte, but it will allow implicit type conversion when you try to convert byte to int. Okay, so in one direction, some directions it will allow without you doing anything. In some directions you have to force it. It is okay even if the data is lost, you still convert it to whatever I want. In that case you have to do explicit type conversion, like int to float, float to int. For int to float it is implicit, you don't need to say anything. But for float to int it will not allow, you have to force it. In that case it should be explicit type conversion. Similarly, for byte to int it is implicit, you need not do anything. But for int to byte you have to do explicit type conversion. Okay, so explicit means you have to say explicitly, that's all. That is the difference. Implicit means you don't need to say anything, it will understand, it will do it automatically. All right, so this example we saw. Now let's look at this. Okay, so let me comment this for the time being. Yeah, so initially first let's convert byte to int. Okay, so byte I am storing 20 and then I am trying to convert that to int. I am trying to store that value to int. Okay, so will it work or no? It will work, right? Because byte is smaller than int, so you need not do anything. It worked. Okay, now let's say n1 is int and n2 is byte. All right, now let's try to run this. It's not allowing. All right. Although there is no data loss because 20 fits in 1 byte also, but it is not allowing. It doesn't care. It doesn't look at the particular number. It looks at the data types. Okay. Larger data type, you are trying to convert to smaller data type. That's all it looks at. So you have to force this to be byte. So you have to give explicit type conversion. All right. Now let's run. Now it worked. Okay. Now let us give a slightly larger value to this. Say 2000. 2000 will not fit in byte. Byte maximum value is 255. Okay. But still we are forcing it. It will work, but it will not print 2000 because 2000 will not fit in byte. It will truncate it. Whatever bits are remaining, whatever is the value of those bits, it will print only that. Okay. You see, initially it printed 2000 because in N1 you have space for 2000, but N2 is a byte. So it will truncate the bits and whatever remaining bits are there in the last byte, it will print only, it will convert that to decimal and print their value. Okay, that is the difference. So implicit means you need not do anything. If there is a possibility of converting one data type to another, it will do it. Explicit means you have to force it, that convert. You have to explicitly say that you have to convert. Okay, but sometimes even if you say explicitly, there are some data types which it will not convert from one to another. Okay, so let me comment this also now. Suppose I say string, again like name equal to, no actually let me, so let's try to run this. This will not work, right? Cannot implicitly convert type string to int. Okay, let's try to do it explicitly. All right. Even now it is not converting. Okay, cannot convert type string to int. It's not giving the reason. Okay, now one may think, okay, how do you convert a string like name like Hyderabad to int? Let's give some string with only digits, say 1 2 3 4. Okay, this should be converted to 1234. At least let's see if it does that. Even that it is not doing, right? Basically these are non-compatible types. Okay, here actually what it needs to do is, it is not like 1 2 3 4 is stored in 4 bytes or 2 bytes, int takes 4 bytes, it just needs to expand that. No, here 1 2 3 4 is stored entirely differently. It's like ABCD. You need to get the ASCII value of A, ASCII value of B, ASCII value of C. They all look very different. So you need to basically convert all of them into decimal values, but not like independent decimal values. The decimal values should look as if finally you are getting 1234. Both are different cases. Okay, so here you need to take character by character and then you need to group all the decimal values, all the binary values, convert them to a decimal value such that when you take all the bytes together, it will give you the decimal number. Okay, so it is not like expanding the size or contracting the size. This is entirely different. The values themselves are very different in the binary representation. Okay, so in that case we have slightly complex functions. We have two options. We can use a function called convert dot, let me remove this, convert dot to int32 name. Okay, and let me print n1 now. Okay. You see, it worked. All right. So this is one way of converting a string to int. But if I give something like this, it doesn't work. You should only give such a string which is of the form of a number, right? So this will not work. You have to give some number as a string. Okay. All right. Now another way of converting string to int is the data type dot parse string name. Now again you can print n2. Okay, let's see that. That also worked. So these two ways. Now if you want to convert to a different data type, say if you want to convert it to a long, then you should say to int 64, because here you need to use .NET data types, not C# data types. So you need to know what are .NET data types, right? So here you know int means int 32. So you should say convert dot int 32. Long means int 64. Okay, so you should use these corresponding data types if you are using convert. If you think it is difficult to remember these .NET types, use the parse thing. Each data type will have parse method. So you can convert this to int.parse, or if you want to convert it to long, you can say long.parse, or if you want to convert it to float, you can say float.parse, like that. Okay, so this is the third type. It is not implicit, it is not explicit. You are calling a function. You are saying parse this, break it down, analyze this, and then convert it to a number. Okay, it is not inherently a number, right? It's inherently a string, whereas byte is inherently a number. You just need to expand it to int. Okay, but string is not inherently a number. It is some characters. You should understand what these characters are, and you should convert this to a cumulated decimal number. Okay, so the process is different. Even explicit type conversion won't help there. Okay, so this is the third type. All right, so these are the three types of type conversions. We looked at implicit type conversion, explicit type conversion, and conversion of non-compatible types. All right, yeah. Okay, so let's stop here.